Hey everybody, this is Chapter 2, Section 3. Title is Solving Multi-Step Equations, begins on page 94. We're still going to use the same steps that we used in Sections 1 and 2. What's my variable, what's being done to it, what's the inverse, and so on. But sometimes you have to look for a few other things before you can use those steps that we've already used. For example, you're going to look for the following things, and you're going to make sure that they're in this order. First, you're going to look to see if the problem has a distributive property that you can do. Second, you're going to look to see if you can combine like terms. And third, you're going to look to see if the problem has fractions or decimals. We're going to cover all of those in this section. By the way, this is a little bit longer section, so make sure you're prepared for that. Okay, stick with me. First example, what's the solution of 11m minus 8 minus 6m equals 22? In this example, pardon me, you can see that on the left-hand side we have two like terms. But we have to look for things in order. Is there any distribute in this problem? There's no parentheses, so no, there's no distributive property. Are there any like terms? Yes, the 11m and the 6m are like terms, so we can do 11 minus 6, and that gives us 5m. We haven't done anything with the minus 8, so it comes down. We haven't done anything with the 22, so it comes down. Next, are there any fractions? No, there's not. Are there any decimals? No. So now, I just continue with the other steps. My variable is m. It's being multiplied by 5 and subtracted by 8. I need to deal with the subtracting 8 first, so the inverse of that is adding 8 to both sides. Then I need to simplify. Subtracting 8 and adding 8 are inverses, so they cancel. On the left-hand side, I get 5m. On the right-hand side, 22 plus 8 is 30. My variable still isn't by itself. It's being multiplied by 5, so I need to do the inverse, which is divide by 5. Do that to both sides. Multiplying by 5 and dividing by 5 are inverses, so they cancel. I have m on the left, and on the right, 30 divided by 5 is 6. That would be my answer. Again, just like always, I can take that, I can plug it into my original problem to check and make sure that I have the correct answer. Example 2 is a word problem. Noah and Kate are shopping for a new guitar strings in a music store. Noah buys 2 packs of strings. Kate buys 2 packs of strings and a music book. The book costs $16. The total cost is $72. How much is 1 box of strings? So what we're trying to find is how much 1 box of strings costs. That's in yellow there. And so we're going to say that strings is represented by the variable s. Now, Noah buys 2 packs of strings, so that would be 2s. Kate buys 2 packs of strings, so that would be 2s. And she buys a music book. The music book costs $16, so we have 16 in blue in our equation. The total cost is 72. Total means put it all together. That's where your equal sign comes from. And you get 72. From there, we try to figure out what we need to do next. We need distributive property. No parentheses, so there's no distributive property. Like terms. Yeah, the 2s and the 2s are like terms, so we can put those together and get 4s. 16 comes down, 72 comes down. S is my variable. It's being multiplied by 4 and added by 16. I need to take care of the one that's farther away from the variable. So that's the adding 16. The inverse of adding 16 is subtracting 16. So I have to do that to both sides. Now I simplify. Adding 16 and subtracting 16 are inverses, so they cancel. On the left, I have 4s. On the right, 72 minus 16 gives me 56. My variable is still not by itself. It's being multiplied by 4. The inverse of multiplying by 4 is dividing by 4. Do that to both sides. Multiplying by 4 and dividing by 4 are inverses, so they cancel. On the left, I have s. On the right, 56 divided by 4 is 14. What that means is, remember s stood for box of strings. So 1 box of strings costs $14. Next one, what is the solution of 18 equals 3 times the quantity 2x minus 6? First thing you should notice about this one, it's got parentheses. That looks like distributive property, and it is the distributive property, so we have to do that first. So we do 3 times 2 and get 6x. 3 times negative 6 gives me negative 18. Next, we look for like terms, not on the same side of the equal sign. Any fractions or decimals? Nope. So we have to continue with our normal other steps. My variable is x. It's being multiplied by 6 and subtracted by 18. We have to get rid of the subtract 18 first because it's farthest away. The inverse of subtracting 18 is adding 18, so we do that to both sides of the equal sign. Subtracting 18 and adding 18 are inverses, so they cancel. On the left, 18 plus 18 is 36. On the right, I have 6x. My variable is not by itself. It's being multiplied by 6. The inverse of multiplying by 6 is dividing by 6, so I do that to both sides. Simplify. Multiplying by 6 and dividing by 6 are inverses, so they cancel. On the left side, 36 divided by 6 is 6, and I have x on the right. Again, it's the same thing if you just rewrite it like this. An equal sign, you can flip-flop around it, so I can move the x to the left and the 6 to the right. So my answer is x equals 6. Again, I can plug it up into my original equation to make sure that I have the correct answer. I'm just like you. I don't like working with fractions. Okay? Wouldn't it be nice if we could just make them go away? There is a way that in these problems we can get rid of our fractions so we don't have to deal with them for as long. If there is a fraction in your problem, you need to multiply every part of the problem by the least common denominator, the LCD. Multiply every single part of your problem, both sides of the equal signs. Okay? If you do that correctly, all of the fractions will become integers. The fractions will be gone, and you'll just have things like whole numbers left. Here's an example of how to do that. What is the solution of 2b over 5 plus 3b over 4 equals 3, or 3 over 1? Okay? Look at my denominators. I have a 5, a 4, and a 1. If I'm trying to find the least common denominator, okay, this is the way it was taught to me a long time ago. My denominators are 5, 4, and 1. So what I'm going to do is I'm going to count by 5s for a while. Okay? Now I'm going to count by 4s for a while. I'm not going to count by 1s yet, you'll see. If I look at the list for 5 and 4, what's the first number that shows up in both lists? Well, 20. Now the reason why I didn't count by 1s, if I count by 1s, am I going to eventually get to 20? Sure I am, so I don't have to write that one out. My least common denominator is 20. That's the first number that shows up in both lists. So I have to take my problem, and how many parts are there? Well, there's the 2b minus 5. That's one part. There's 2b divided by 5. There's 3b divided by 4. That's the second part. And there's 3 over 1. That's the third part. There's 3 parts of this problem. I have to multiply all of them by 20. Okay? So 20 times 2b over 5 plus 20 times 3b over 4 equals 20 times 3 over 1. I multiplied all 3 parts by 20. Now I'm going to multiply straight across. 20 times 2b is 40b. There's really a 1 on the bottom there, so it's 1 times 5. 20 times 3b is 60b. 4 stays on the bottom. On the other side of the equal sign, 20 times 3 is 60 over 1. Now what I need to do is I need to simplify these fractions. 40 divided by 5 is 8. 60 divided by 4 is 15. 60 divided by 1 is 60. And right there, all of my fractions are gone. I don't have to deal with fractions anymore. Now it's just a normal problem like we've been doing. If we continue with our steps, is there any distributive property? Nope. Any like terms? Yep, 8b and 15b gives me 23b. On the other side, I still have 60. Okay. My variable is not by itself. It's being multiplied by 23, so I need to do the inverse, which is divide by 23. Multiplying by 23 and dividing by 23 are inverses, so they cancel. And I get b equals 60 over 23. Let me double check and see if I can simplify that fraction. Nope, there's nothing I can take out of a 60 and a 23, so I leave that as my answer. Okay? I can't turn that into a decimal. I can't turn that into 2.6 or something like that, because my problem had fractions in it, which means my answer cannot have decimals. You can't switch from the beginning of a problem to an end of a problem. So that would be my answer for this one. I don't like working with decimals either. It would be nice if we can make those go away, and we can, doing something similar. Here's the steps for getting rid of decimals. Count the number of digits after each decimal point. Okay, we'll do an example to make sure you understand these. Find the biggest number of digits after the decimal point in the problem. Take the number 1, and however many the biggest number of digits after the decimal point was, that's how many zeros you put after the number 1. So you're going to end up with like 10 or 100 or 1,000, something like that. Just like in the last problem, when we multiplied everything by the least common denominator, whatever number you get, 10, 100, 1,000, or whatever, you multiply every part of the problem by that number. If you do this correctly, all of your decimals will become integers. Now, they're going to be big integers most of the time, but they will be integers. You won't have to worry about decimals anymore. Okay? Let's do an example. Hopefully you wrote those steps down, so when we go through the next example, you can see each step as we go. Here's the problem. What is the solution of 0.5x minus 2.325 equals 3.95? All right, first step, count the number of digits after each decimal point. So in this first part, 0.5x, how many numbers after the decimal point? 1. In the second one, 2.325, how many after the decimal point? 3. And in the last one, 3.95, how many after the decimal point? There are 2. Find the biggest number of digits after the decimal point. Well, the biggest one of those numbers is 3. Okay? Here's what we're going to do to it. We're going to take the number 1, and we're going to write 3 zeros after it. 1, 2, 3. So we're going to multiply every part of this problem by 1,000. Okay? Multiplying by 1,000 is the same thing as moving the decimal, all of the decimal points 3 places. Okay? So what we can do is we can take 0.5 and move the decimal point 3 places. And we end up with 500. We can take the next one, 2.325, move the decimal point 3 places. And we get 2,325. On the other side of the equal sign, we take 3.95, move the decimal point 3 places. We get 3,950. All of the decimals are gone. We've got big integers, but still they're just integers. We can follow the same steps we have been. X is my variable. It's being multiplied by 500 and subtracted by 2325. We want to get rid of the one that's farther away first. The inverse of subtracting 2325 is adding 2325. Do it to both sides. Subtracting and adding are inverses, so they cancel. On the left, we have 500x. On the right, if we add those two numbers together, 6275. Divide by 500 because our x is being multiplied by 500 and dividing is the inverse. Those cancel. Don't forget we have to do it to the other side. Get my calculator here. What kind of answer should we get? Well, our problem started with decimals, so my answer can't be a fraction. So we get 12.55 is the answer. Again, even with this one, you could plug it back in and check your answer as well. Okay. There's practice problems for this set.